Hello everyone. Today's lesson is on the quadratic formula, which is another tool on our endless quest to solve quadratics. Now, you might be thinking, we already know how to solve by square roots, we know how to solve by factoring, and we've been told that by completing the square you can solve basically any quadratic. So why do we need another way to solve quadratics? So to show you why we might need another way to solve quadratics, let's take a look at these two problems. So this first problem, we have a quadratic term and a linear term, so we're not going to be able to solve by square roots. Let's just assume I already tried to solve by factoring and it didn't work, so now we're on to completing the square. So to start with completing the square, I'm going to subtract over my constant. So I'm going to subtract 20 over, and I'm going to do two steps in one. I'm going to subtract that over. I'm also going to factor out the 3 from my quadratic and linear term. So I factor that out. I'm left with x squared minus 8x equals negative 20 as I move that to the other side. Now to complete the square, I take half of my linear term, negative 4. I'm going to square that. That equals 16. So now what I need to do is I multiply the 3 to that 16 to show me that I'm going to add 48 to the other side of the equation. I wind up with 3 times x minus 4 squared equal to 28. So now I divide by 3, I get x minus 4 quantity squared equals 28 over 3. Take the square root of both sides, and I get x minus 4 equals positive and negative root 28 over root 3. Now to rationalize the denominator, I need to multiply by root 3 over root 3. So x minus 4 equals positive and negative, what is that, 84 all over 3. 84 breaks into 4 times 21. So I get x minus 4 equals positive and negative 2 root 21 over 3. Last step, add the 4 over. I get 4 plus or minus 2 root 21 over 3. Now, obviously that was not an easy problem, but that problem is actually a piece of cake compared to number 2. So let me get some of this out of the way, and let's look at number 2. So if we look at number 2, if I try to do the exact same thing that I just did, what winds up happening is I subtract 11 to the other side. I get negative 11 equals, and let's factor out that 4, except 7's not really divisible by 4, so what I'd wind up with is x squared minus 7/4 x. And now if I continue with what I did in the last problem, I'm going to have to take half of 7/4, which is 7/8. I'm going to need to square that, so I get 49 over 64. And then I'm going to need to add 49 over 64 to negative 11, which all this seems like way too much math for something like completing the square that was already a little tedious to begin with. So let's talk about how the quadratic formula can actually make our lives easier, and so we don't have to deal with these crazy fractions on top of completing the square. Okay, so basically to use quadratic formula, we need to find out what quadratic formula is. And really all quadratic formula is just a quicker way to get to the result of completing the square. So to do this, we're going to take a quadratic function that we did not already plug in a value for a, b, and c for, because again, a, b, and c really just represent numbers that should go into the quadratic equation, but we're just going to solve a quadratic without a, b, and c in it. Because if we do that, we can come up with a formula that we can just plug our a, b, and c values into without having to go through completing the square every single time. So our first step in completing the square is we are going to move our constant to the other side. So I get negative c equals, and again, I'm going to do this at the same time. I'm going to factor out that a. So I factor out a, and I get x squared plus b over a x, right? B divided by that a gives me b over a. Now the next step is we take half of that. So b over a divided by 2, that's like saying what's b divided by a divided by 2. So I get b over 2a. And now I square that, and I get b squared over 2a squared is 4a squared. Now, before I go to add that to the other side, I need to multiply by this a that's out in the front. A times b squared over 4a squared is actually just b squared over 4a. So that's what I'm going to be adding to negative c. Now, if I want to add that to negative c is going to have the same denominator. So I need a denominator of 4a, which means I need to multiply c by 4a. So what I get is negative 4ac over 4a. And when I combine these two things, I get b squared minus 4ac all over 4a equal to a times, now again, we just completed the square, so we can factor this now, x minus b over 2a squared. So now what I'm going to do is I'm going to divide both sides by a. So I divide by a, which means, again, I'm multiplying another a to the denominator. So I get x minus b over 2a squared equal to b squared minus 4ac over 4a squared. So now the next step is to square root both sides. When I square root the numerator here, basically because I have such a large expression where not everything's squared, I can't really square everything. I'm going to move this over here where I have a little more space, and I wind up with x minus b over 2a equal to the square root of b squared minus 4ac divided by, now the square root of 4a squared, those are both perfect squares, so I can actually square root both of those, and I get 2a. Okay, so I get positive and negative b squared, square root of b squared minus 4ac all over 2a, and my last step is going to be adding the negative b over 2a, which luckily they have the exact same denominator, so I get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this is obviously very confusing. I'm not going to expect any of you guys to actually know how to do this. I'm not going to test you on this. However, it is important that you understand this end result. This end result means that every time I complete the square, the numbers a, b, and c wind up in this exact formula to give me my exact solution. So here we have it, our quadratic formula, a method of solving quadratic equations that can be used to find exact solutions. The solutions of any quadratic equation of the form ax squared plus bx plus c equals 0 can be found with x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a, where a does not equal 0. Why can't a equal 0? Well, because first of all, if a equaled 0, a times x squared up here, you would see 0 times x squared, that's just 0. So I actually wouldn't even have a quadratic function. But also, with the 2a in the denominator, I can't divide by 0. So a cannot be 0 because we cannot divide by 0. Now, this formula might be, it might look like a lot going on at the same time. Luckily, we have this thing called the discriminant. The discriminant is the part that's inside the square root, b squared minus 4ac. The reason that this is important is because we know that we cannot square root negative numbers. So if we first, before using the quadratic formula, plug just into the part that says b squared minus 4ac, and we determine that b squared minus 4ac is less than 0, we know there are exactly 0 real solutions, which means we actually don't have to go through with solving the rest of the problem. We already know that the answers are imaginary. Now, if we plug into b squared minus 4ac and we determine that b squared minus 4ac is 0, there's exactly 1 real solution. And if you think about that, that makes sense because if I take the square root of 0, no matter if it's positive or negative 0 is just 0. So what that actually does is if we plug into b squared minus 4ac and find that it equals 0, we only have to do the negative b over 2a part of the formula, because we know that the square root is just going to be 0. It's really not going to affect anything. Now, when b squared minus 4ac is greater than 0, there are exactly 2 real solutions, and that's really the case where we have to use the entire formula. Luckily, if we have to use the entire formula, we already just figured out what goes into the square root. So really all we need to remember now is that x equals negative b plus or minus the square root of the discriminant all over 2a. And that's a little easier of a formula to remember. So if you just remember the discriminant part and you remember this part, it should make your life a little easier. So let's look at a couple examples. All right, so here's 2 examples. Let's break them down. Let's try them out. Let's say we already tried to solve by factoring. It didn't work. We look at it. We say, all right, let's try to complete this square. In this first problem, I'm going to have to divide 3 from 17 when I factor it out. That's really not something I want to do. So we're going to have to use the quadratic formula. So the first thing I need to do is I need to make sure that my quadratic's in standard form, which it is. I have a number times x squared plus a number times x plus a constant. So I have my quadratic term followed by my linear term followed by my constant, which means it's in standard form. It's ready for me to use the quadratic formula. So I'm just going to label my a, b, and c so I know where to place them into my formula. And like I said in the last slide, the first thing we should actually do is use the discriminant, because if we've determined the discriminant is negative, then we can immediately say the answer is imaginary. We don't really have to go through with much more work. So my discriminant formula is b squared minus 4ac. So my b is 17. So b squared is going to be 17 squared, so that's 289. And I'm going to subtract 4 times a times c. So 4 times 3 times 10, that's going to be 4 times 3 is 12. 12 times 10, that's 120. Now, if I subtract those two things, I get 289 minus 120. That's going to give me 169, which is actually a perfect square. So what I said in the beginning about this not being factorable isn't true, because when I go to square root 169, I'm going to get a perfect, perfect rational number. And that means I'm going to have 2 integer solutions. So that means this actually was factorable, but that's okay. Let's just keep going. So now that I have my discriminant, I can plug into that easier formula, negative b plus or minus square root of the discriminant over 2a equals x. All right, so x is going to be equal to negative, my b again was 17, plus or minus the square root of 169 over 2 times a, which is 6. So, square root of 169, like we were saying, is 13. So I get x equals negative 17 plus or minus 13 over 6, which, again, luckily, square root of 169 was a perfect square. So that means this is actually, we can actually combine like terms and simplify this. So if we do negative 17 plus 13 over 6, negative 17 plus 13 is negative 4 over 6, so we get our first solution as negative 4/6, or negative 2/3 simplified. And then if we do negative 17 minus 13 over 6, negative 17 minus 13 is negative 30. Negative 30 divided by 6 is actually just negative 5. So here are my 2 solutions. Okay, so now let's move on to our next question. Again, I look at it, we got the x squared first, then the x, then the constant. So this is already in standard form, so I can already label my a, b, and c. I'm going to use the discriminant first, b squared minus 4ac. My b squared, 12 squared is 144, minus 4 times a times c, so 4 times 4 times 9. So that's 4 times 4 is 16. 16 times 9 is 144. Now 144 minus 144 equals 0. Now remember what we said in the last slide. If something equals 0, that doesn't mean it's imaginary. It means when I take the square root of 0, I'm just going to get 0. Positive and negative 0, just 0. So the square root of my discriminant isn't really going to do much for the rest of my formula. I'll still put it in just so we're consistent. But now when I go to do my negative b plus or minus root discriminant over 2a, I'm going to get x equals, and the negative b is negative 12, plus or minus square root of 0, which again doesn't do much for us, all divided by 2 times a, which is 8. So I get x equals negative 12 over 8, which is going to simplify to negative 3 over 2. And that is my only solution here. Okay, now what I want you guys to do at home is to try these two problems out. Be a little careful with number 3. If you notice, number 3 is not actually in standard form yet because we have to move that negative 5 over to the rest of the quadratic to get it in standard form. But, follow what I was doing. Find your discriminant first. If you get that negative discriminant, remember that means it's imaginary. You don't actually have to go through with the rest of it. So at this point, just pause the video, try these problems out, and after you pause it, I will put up the full solution so you can check that you did it right. And if you didn't do it right, you might want to rewind back in the video to watch those first two problems again, see how I did everything. Okay, give them a try, pause the video, and then when you're done, unpause to see the solutions. Okay, so here are the solutions. If you look at number 3, a big problem people seem to have a lot is that when their b is negative, they forget that when you square a negative, you get a positive. So this negative 9 squared is actually 81. And then I'm subtracting 4 times 3 times 5, which is 60. So that gives me a positive 21. I take that 21, throw it into my discriminant, take the square root of it, which is not simplifiable, and it's not a perfect square. So I just kind of keep it in the square root. Negative b, so negative of negative 9 is positive 9. So I get positive 9 plus or minus the square root of my discriminant 21 all over 6. And some people might actually look at this question and say, hey, all of these numbers are divisible by 3. Can't I simplify this fraction? You actually can't because the square root of 21 is not divisible by 3. 21 itself is, but not the square root of 21. So you got to be careful with that too. Now, if we move on to number 4, number 4 is the situation we do like to see because when we take a, b, and c, again, our b is negative, so you got to be careful with that. Negative 2 squared is positive 4. But I mean, whether it was positive 4 or negative 4 here, you still should have got the right answer because you take that small number, 4 or negative 4, which again, it is 4, but, just in case you got that wrong, you still should have got a negative discriminant because I'm taking this small number 4, I'm subtracting 4 times 7 times 8. I wind up with negative 220. And once I see that negative, again, that's best case scenario. I know I have a negative discriminant. I know if I take the square root of a negative, it winds up with an imaginary solution. So at this point, I don't have to go through with the rest of this formula. I can just say this is imaginary. Okay, so what you guys need to work on now is the rest of that packet. Try out those problems. Message me on Google Classroom or on Google Meet if you have any questions. And, try that practice. Tomorrow we'll work on some more practice and we can actually interact a little bit more on Google Meet with any questions you have.